same thing. It was, so the same thing happened. It was basically the same thing. I was just completely disorganized after we got the news. So, but let us begin today. And I'll have a small assignment for you at the end, so that tomorrow you have, instead of having a lecture, you will have time to do your small assignment. So with that, shall we begin? Or is there any comment before we can begin? Is there any question? No? Yeah, okay?
No, Doctor, we can proceed.
Okay. Okay, let me just share my screen. I think you all know me. So, but if there's any new person, my name is Shebanya Kaisiki, lecturer in the Faculty of Science. The course outline will have more details about how you may contact me. But we are basically going to look at the course unit ICT Design, Selection and Implementation. Basically, this course unit revolves around how we can effectively design, select, how we can effectively implement our ICT solutions. And the principles basically around that. It is not a very technical course. It's more management. It falls more on the side of management and just having those specific tools that will help you make those decisions, effective decisions for the organization. Basically, this course unit is going to help us, it's just going to give us those tools, like I said earlier, just to be able to make those appropriate decisions as a head of an ICT department or as management in ICT. If we are to look at just some of these things that we see that the course is going to try and look at, we're first of all going to look at the theories and the terminologies. Those theories and terminologies that help us to identify critical ICT systems, be able to describe them, be able to analyze. Analysis is important. Look at how you can design ICT systems. And then also how you should be able to implement a generic or self-modified development life cycle. So in this course unit, where we have several terms we are going to look at, this introduction, this particular session, we are going to visit the term development life cycle quite a bit. We already have an idea what this term means from, if those who did IT or computer science, you've encountered the term, the development life cycle, system development life cycle. Those terms we've rotated about them. Now, when we are thinking about it now, we may think, oh, we are actually going to be looking at software development or system development, or information system development. Not necessarily. This is not the case. We're looking now at the management side of things. Now, we are going to look at methods that help us to implement ICT projects, because that's essentially what you're doing when you're carrying out ICT selection, design, and implementation. That's essentially what we're doing. We are going to be introduced to some methods. We're not going to have one particular method. We're going to be introduced to the idea that there are methods that help us do this. What method you select depends on what is appropriate at the time, or what is convenient for you as the ICT manager. So what we shall be looking at essentially will be that we shall see things like system scope, how far should our system go, a requirements analysis, and stakeholder management. These are the key 3 points that we shall be looking for in any methodology that we want to use. So this particular course unit is essentially there to give us an overview of issues and concerns that are related to the selection and implementation of ICT, issues and concerns. So it's essentially going to look at those things that surround them that will help you come up with appropriate design and selection. Why is it that we're not specifically looking at the design and implementation, having something concrete? Because each situation is unique. Each situation is unique. I always think about it in terms of dresses. Ladies, when you look at women, we are very particular with fashion. So the way we dress, that the particular dress I will pick may not be that the dress my sister may pick or my friend or otherwise. My body shape is very different. Our body shapes are completely different. Our personalities are different. So therefore, it's not easy. It's not something to easily say that there's one dress, there's one size that fits all. It's also the same thing with systems. Systems are particularly unique to the context in which they are going to be applied. So we can't say we have one specific method for doing something. So that is why this course unit is going to look at those issues and concerns that are related. Yes, those issues and concerns. We want to look at best practices, the methods that exist, and so on and so forth. At the end of this course unit, a student should be able to discuss ICT architecture within the scope and context of selecting an ICT system. Yes? So you should be able, first of all, to understand the context for which you want to implement a system. You should be able to define a scope and for the intended ICT architecture, where it's going to be, you essentially come up with an ICT architecture for a particular context and a particular scope. You should be able to transfer business case into a data architecture and data and network architecture. So we should be able to see that there are business cases, which we then translate into an architecture. You should be able to discuss the issues of network design. You should be able to draw up a functional design for a data and network architecture. Now, a key thing for anyone who has looked at systems, you understand that systems are not just hardware, they also include people. So we should be able to look at, to select suppliers and steer an implementation project. Now, when we are looking at design selection and implementation, one of the key things we should understand is we're not necessarily looking at systems that we are developing in-house. No, even a system that is being bought or a system that we are outsourcing that is coming in as a service can also fall in this category. We are generally looking at any system that either we are buying off the shelf, one that we are building from scratch, or one that we are essentially going to get as a service from or outsource, in other words. So with whatever it is, it still falls under this topic of selection, of design, selection, and implementation. Now, what exactly shall we look at? Number one, we shall look at system selection. So when we're looking at system selection, we're essentially going to look at the life cycle, the system life cycle in relationship to the system cost. So this is where the point I gave earlier, where I said you'll be looking at either are you building or are you buying? What are the trade-offs that we're going to make if we buy or we build our own? So all of those essentially also still fall in the system life cycle. We shall look at benchmarks and standards used to evaluate ICT implementations. Then we shall look at a selection of ICT implementation strategy or approaches. So that is regarding to system selection. Then we come to system ownership. So here we shall look at distributed ownership, distributed responsibilities. We shall discuss all of these in detail. So the first two, we're looking at selection and ownership. So the last one we shall look at will be implementation. So in implementation, we look at the design process, design of data, design data architecture, that is the design of the communication architecture, the security measures, management structures, implementation principles, and delivery. So we shall look at all of these in detail. This will be the content that we shall look at. But first, we want to look at the context or the background to ICT design, selection, and implementation. What this essentially means is that we are going to discuss the terminologies and that come under ICT selection. So these are the objectives that we're going to look at. I don't want us to go through them line by line. You can read through them, but these are the things we want to look at. They are quite straightforward. So let us start immediately with the first concept, which is system development. Now, under system development, you find different terms. The word system, information systems, system design, and systems development. Let us look at each of these terms or each of these concepts so that we remind ourselves. We already know them from our undergraduate degrees, but let us look at them again just for the sake of it. So the first thing is what is a system? Now, we've had this before, we've seen it, and we've seen systems of different kinds. We already know that systems are made up, it's basically a group of interrelated components that function together, okay? So we already know that. Some of the systems we already know, like biological systems. We have digestive systems, which one knows starts from the mouth and from where you put food and where you take it out. You have the respiratory system, which starts from the nose and onwards. That is a system. Now, if you realize every single part works together. My mouth has the teeth, it has the tongue it receives food, all the parts will carry out what they're supposed to do. My salivary gland will produce saliva to help to start the breakdown of the foods. My teeth will also do their job. Then the food will go through my throat to the stomach, to the small intestines, the large intestines, and so on and so forth. Each part has a function, yeah? Each part has a function that it performs. So essentially, we know that each part this basically then tells us the interconnected components which function together. Now, if there's a part that doesn't work properly, for example, if I have no teeth, or I have very few teeth, like you see with the elderly, then the elderly begin to eat very soft foods because digestion is not beginning from the mouth. If I've got ulcers, that process of digestion is going to be affected. If I have anything obscuring the intestines, then that's also going to affect the digestive system. The same thing goes with the respiratory system. I think we have all seen it, especially in this time of COVID, the COVID virus, which begins affecting the respiratory system from the nose to the throat, going all the way to the lungs, and so on and so forth. So you really see that if there's just one part that is not working, it affects an entire system. So when we come to the physical systems that we see, yeah, physical systems like mechanical systems, many of you may have cars. If one part of the car is not working, the entire car may fail to function. We have also seen the electrical system, our computers, if something doesn't work, chemical systems, and so on and so forth. Then you come to the social systems. The social systems involves human beings. So when we come to human beings, we're also looking at social structures. Look at the simple example of a home which has a father, mother, children. If you have one person not present, maybe the person dies, or you have an absentee father or an absentee mother, that automatically affects the other family members. It will affect the spouse, it will affect the children, and so on and so forth. We hear things today of people saying that, oh, we have a great deal of problems in our country today because of the breakdown of the family structure. These things are spoken about over and over again. So when we think about it, we have seen systems around us, and we understand essentially the need for all components to work together. Now, when we think about, let me just a thought about system thinking. The system thinking part is essentially examining the structure of the parts of a system and the relationships between those systems. Also, this is a key point, especially when we come to think about system analysis. So this is where system thinking comes about. So now we come to the core, some of the core parts of our course. So we look at information systems and what they are. So when we talk now, we're talking about information systems. One, we add data, the term data, because data is the very first the beginning part of information. Two, we begin to talk about processes, because this data goes through processes. We then begin to talk about information technology, because when we begin to talk about data and processes, then information technology must come in. The last part is what I leave out. I come to this, the most important part for me, which I think is the most important part, is people. People are part of information systems, and this is a key point. Later on, when we begin to talk about stakeholders, you find stakeholders are not just users, stakeholders are management, stakeholders are people who necessarily may be external, not within an organization. So these people are extremely important. Look at a simple thing like a website. When you talk about a website of an organization, you're going to talk about stakeholders, including, let's say, who is supposed to visit your site, your clients. Those are stakeholders. And when you're building a website, you have to think about them. You don't only think about, oh, what does the marketing department want to put out there? What does your PRO want to put out there? What does management want out there? You also include the clients. What do the clients want to see? So those are the stakeholders, yeah? These are the people, and these are key points of a system. So here we have just an outline of what an information system components, the basic components of an information system, the hardware, the software, data, people, and processes. So these are just reminders of things we have seen earlier. So we look at another term, system design. What is system design? So system design is basically a problem-solving technique. It's a problem-solving technique which is looks at improving an original system. So when essentially what we're saying is, when we come to system design is not a system is not coming into a very fresh ground where there is nothing. No, there is an existing system. No matter like what the case, there is an existing system. And the system that you're coming to use is essentially coming to improve on what is existing. So there must be a clear understanding of the original, what needs to be improved, and so that when you bring in the new system, you're basically bringing in an improvement. So when you carry out your evaluation, you indicate that improvement, the improvement that is being brought about. So the system design is basically a process of defining the architecture, components, modules, interfaces, and data for a system to satisfy certain requirements. So that process of design, you're defining the architecture, the components, modules, interfaces. I remember one time we carried out an information architecture for the UMU website when I was still head ICT. And we developed that architecture and presented it to Senate. So that was just for the website. You may be designing an architecture for anything. It could be the network, it could be a database system, whatever it is, you need to come up with that architecture plus its components. So when we look at system design, you may see it can be seen as the application of system theory to product development. So the theories are some of the things we need to look at. Those issues behind the theories. Those are some of the things we're going to look at. So what is system development? So we've looked at design. What exactly then what does system development become? So once you've set up your design, you need to then begin the implementation. So the system development part is where you set up activities, methods, best practices, deliverables, and automated tools that stakeholders can use to develop and maintain information systems. So you're basically starting the process. You're starting the process, and you also actually begin implementation of a new software application or program. So you can think of it as creating and maintaining a system. So the development, there's the design part, then there's the development part. You're actually beginning the creation process, which continues on to maintenance. Yeah. Here, the system development part could also include customizing the internal development of a customized system, creation of a database, or acquisition of a third part. So the development process may not necessarily be that of something developed internally, but even when you acquire something from somewhere else, it's also part of the development process. Now, we don't want to mistake the two terms, to mistake it for program development. There's systems development, and then there is program development. So you have you can develop a program, just a small software application, which deals with hardware, software, and data. That is a program. But when we're talking about a system, remember we're talking about components. Remember the components we talked about: hardware, software, data, processes, people. So we should see all those components when we are developing a system. But if we're developing a program, you may not have people or procedures as part of it. I hope so far we are okay. Do we have any questions so far?
No, Doctor, we okay.
Okay. Now, the system development process is one of those processes that can be extremely difficult and challenging. It's one of the most difficult and most challenging. I think for me as head ICT, that is one statement, that my period as head ICT at UMU, it's one thing that I can say truly, that I saw was quite a bit of a challenge. The only time I think I saw a smooth transition was when we were going e-learning. I think that is where we had challenges for sure, but I think that was one of the system implementation systems that implementations where I think stakeholders were really 100% involved. But for many projects, when a system is being developed and implemented, there is usually quite a bit of challenges that are seen. One is trying to determine the requirements of a system. there's usually some difficulty in trying to determine requirements of a system. And we shall discuss this in a bit later to understand why this part is particularly challenging and some of the common mistakes that are usually made. And I'm sure most of you, in your positions, you have seen this. Requirements are always changing. Yeah, requirements are always changing. I think for most people, since the COVID-19 period hit and we're now going online, we are seeing that as we go online, the demands are changing here and there. We see that at UMU, as e-learning is going forward, we see that requirements are consistently changing. So the users want more and more. The hardware is asking us for more. All these things, management is asking for more and more and more from systems. So this automatically changes, or rather affects, the system development life cycle. Then we also have the rapid change in technology. This is not new to any of you. So these are just some of the things that we experience. Now, it's usually quite common. Some of the things that are affected are budget. The project budget is one of the things that is usually hit the most. Some projects actually fail to achieve the goals they were set out to achieve. And we can see this, I can actually share with you an article which I pulled out for my research students, which was trying to implement a software application to improve communication, but the project was actually a failure at the end of the day. So usually some goals are not met. So we want to understand that the main purpose of this course unit is try to understand those issues surrounding it so that we can try to ensure success of ICT projects and therefore achieve the goals that we want to achieve. Remember, if we go back to the course unit when we began this particular program and why we are doing what we are doing, why this particular program is there, of MSc ICT architecture, design and architecture. Why do we have it? We essentially want to achieve organizational goals, and that's why systems are there. And as heads of ICT or CIOs, you don't want to promise, or rather, you don't want a situation where a team is expecting goals to be met and the system, and it simply doesn't work. And normally the fingers point back at the CIO, the head ICT. Another term we're going to look at in depth, is systems analysis, because this is where we determine our requirements. This is where we want to determine what our requirements are for the user, for the hardware, for the software, whatever it is. This is the section that deals with that. So what exactly is systems analysis? It's again going back to problem solving. Yeah, it's a problem solving technique. Essentially, what the system analysis process is trying to do is, first of all, it focuses on the knowledge, the raw material used to create useful information. It focuses on data. What data will the system handle? How should this data be handled? Who should handle it, and so on and so forth. The processes, the activities, including management, that will carry out the mission of the business. What processes need to be handled and who will handle them? Communication. Who will the system communicate to? Who will the users communicate? How will the users communicate? What will the system interfaces be? Finally, the stakeholders, analysis of the stakeholders, the needs and requirements of the stakeholders. So those are the 4 areas that system analysis looks at, generic 4 areas. So who is a stakeholder? So here, essentially, we're looking at context. Yeah, we're looking at context. Now, context, whenever we're thinking of context, we have to think about something that is going to interact with the system. Whatever it is that is going to interact with the system, that is context. Who is going to be affected, or who is going to affect the system itself? either positively or negatively. What is going to affect the system, either positively or negatively? These are the stakeholders. So the stakeholder is any person who has an interest in an existing or proposed system. Who has an interest, either positive or negative, who will have an interest. So we shall look at things like who are the owners, who are the internal system users, who are the external system users. Now, a key question I would ask all of you, in the context of UMU, who are the owners of Zivasti? I'm sure all of you who know Zivasti, the system. Who are the owners of Zivasti?
Doctor,
you can think about it. Yes, please.
It must be a group of some bright gentlemen around town. Or
Yes.
maybe you can say the government or maybe a certain company could be the owner.
Yes, so it's definitely a group of people that own it. Definitely not UMU. So you would ask questions like, how has that affected that ownership? How has that affected the university? What is the effect of that ownership on how the system is being operated? Take an example. If you go to ICT now, and as a student, and you say, I'm failing to log in onto Moodle. And the first thing ICT asks is, how are you trying to log in? Are you trying to log in using Zivasti, or are you trying to log in using directly to Moodle? And if it says Zivasti, they'll tell you, oh, then you need to contact the Zivasti guides. So you as a user, you're automatically affected by that because you have to go to a third party. We have seen this precisely for undergraduate students who have been doing their exams. And you find a student is sat down for an exam, this 3-hour kind of exams. They've sat down and logged and done the exam. They want to submit the exam, but they can't. So you find those challenges existing. And because ICT, the UMU ICT has limited rights to Zivasti, they can't necessarily help the student. So you already see how ownership there becomes an issue. So in ownership, we are basically looking at who is sponsoring, who is the system advocate. Now, even if you have a system that is owned by a third party, still at the university, still at the organization, any organization, there must be an advocate, somebody who speaks for the system. There must be that advocate. The person who is usually responsible for funding the project. So now the owner has a really significant impact on the system development, in the initiation of a system development project. This person has a serious impact on it. We shall also look at some cases from literature and see the impact of owners of systems. We have the internal system users. So the system users are basically those who are responsible for the communication and transfer and processing procedures. Those who carry out the processes, the system processes, those who are going to push the system processes. These are the internal users. So they're the ones who are involved with creation, collection, processing, distribution, and use of information. Those who handle the data within the system. Then you have the external users, those who will interact with the system outside of the organizational network. I've already given an example of, let's say, a website. An external system user may be a client, for example. It could be a supplier who is accessing that system. So whatever the case, here we have some examples. We have customers, suppliers, partners, and employees. All of these could be external users. we come to another term that is going to be quite popular in this course unit, which is system life cycle and methodology. So we're going to encounter the two terms quite a bit. So the first one, what is the system life cycle? So when we're looking at the system life cycle, we're looking at the system development and then the system's operation and maintenance. Its development and its operation and maintenance. So those are the basic two steps, two parts of a system life cycle. Then we come to methodology. So the methodology is implemented into the system life cycle. Yeah, it's basically those standardized development processes that are used to come up with a system and to maintain it, those standardized development processes. I'm sure when you did your undergraduate project, these were things that were emphasized for you to tell the reader or your supervisor, whoever it is that was reading your project, what method you used to come up with your system. So when we look at the system life cycle, we realize that the system begins with, we start with development, the development process. And in this development process, this is when we apply the method we want to use. Yeah? Whichever method, we've seen many of them, and we're going to see just a few examples in the next slide. This development process converts this into a system which then becomes operational. Yeah? It becomes, the system is now operational and it's operational and it's being maintained. So far, do we have any question?
Doctor, you can continue.
Okay. So on this slide, you can see a number of methodologies, system development methodologies, which can be used. So we are not going to focus on a particular one because the decision to make one depends on the developer or the team that is developing the system or implementing. So any of these can be used. Any of these, even if you're buying something off the shelf. Yeah. Now, this is part of your assignment, which I'm going to ask you to write about. The other parts are coming later. Just read and research about each of the development processes listed above. Just read about them and write something short in your own words, what you understand. Now, one of the things I want to point out is that we don't want to say that there is only one single process you can use or one single method. You may find you want to use a combination of two, whatever it is that you may see. The purpose of this course unit is not to talk about these. You already know them, but you would select the method depending on what you see fits in your particular project that you're managing. So when we're looking at system development processes, it is necessary to choose a consistent information system process or method. Why is that? One, solution. You need to be able to shift resources between projects. When you're using a consistent system development process, you're able to determine, because when you're starting the process, you set your goals, you set your requirements, and you know what it is you want to achieve. Now, as you're developing your system, you keep going back and forth to your original goals. And where you see your original goal may not be achieved, you can shift processes. so that you ensure that you have, that you're basically achieving your goals. 2, because you're using a consistent process, you're also coming up with documentation. Each process allows you or ensures or forces you to document what it is you're doing, so that at the end of the day, when you're going back to evaluate, that documentation helps. 2, it also helps in the maintenance process. And finally, using the development process also ensures quality, because you are evaluating yourself throughout. Each of these methods, as long as you're using any methodology, you're basically going through an evaluation process. Each process requires you to evaluate. I don't know, probably I will also share with you some literature on design science. It's a type of research method, but it's a type of research method specifically for IS or ICT professionals. And one of the things it emphasizes is consistent evaluation at whatever stage of the development life cycle that you're at. So this is where the quality comes in, because you're consistently evaluating what it is you're doing. As ICT people, one of the things that we are prone to, that we can one of the traps we can very easily fall for, is falling in love with our creation, and we forget to realize that we forget to objectively evaluate on whether our creations are actually giving us the results that we need, that the organization actually needs. So when you're using a method, when you have a particular method or methodology that you're using in your system development life cycle, you're essentially being forced to continuously evaluate each stage to see if you're going to or you are achieving the set objectives or the specified requirements. Here we have a classical problem-solving approach. And this is essentially what all these methodologies focus on, or the methods that we are talking, that we've looked at earlier. They all follow, or they all have these 4 parts or 4 stages as part of the methodology. And you'll see it in the literature that I'll give you on design science. 1, you start by studying the problem and its context. You start by understanding the problem, its context, and its impact. Yeah? So as you're designing, you're coming to ICT design, selection, and implementation, everything will start with the problem. What is the problem? What is the context in which it sits? And what is its impact? So there must be a thorough understanding of the problem that exists. Sometimes we may bring a bulldozer for something that may be solved with a hammer. Not so. We may bring a bulldozer or something else for a problem that can be solved with a hammer, simply because you have not understood what the problem is. Yeah? Once you've defined the problem, you then that must be met by any solution. What are those requirements? A colleague of mine was recently telling me, just this week he had a meeting at Makerere. They were setting out requirements for a new university information system. And he was telling me how fruitful. He said they got all the stakeholders, and these stakeholders were able to clearly articulate what their problem was, and therefore then clearly define what their requirements were. And he was particularly excited because he was saying, yes, now we can now begin to define a solution. This is very different from somebody bringing a solution and trying to fit it into your problem. So always it must begin with identification of a problem, the requirements, and then we bring in a solution. Now, in bringing in the solution, you begin by identifying candidate solutions, and then select the best solution in all. Yeah, select the best solution in all that meets the requirements that have been defined. That this, it isn't ICT to define solutions, no. It requires experiencing the problem. And usually it's not ICT that then we design and implement the chosen solution. Now you notice we're saying design and implement. Yeah, we've selected the best possible solution. The best possible solution, we may say, let's develop something in-house. The best possible solution might be something off the shelf. Then we say, okay, in the design process, can we customize it? Can we change this? Can we do that? And so on and so forth. That is part of the design process. Then we implement it. Then we observe and evaluate. Now, key point I want to note, on 5 things you will note, especially in the literature I will share with you on design science, we actually evaluate at each stage. The end, to see are we actually achieving the objective, but we actually evaluate at each stage. Any questions so far?
No questions.
Doctor, we are so far so good.
No?
No question.
Well, okay.
Yes, doctor, we are okay.
Okay.
Yeah.
So now when we come to the, no question, okay. Now, we then think about modeling, because we have now to put what we've talked about, our requirements into look at this in detail because I know most of you know this. You've done this before. Presentation that depicts what a system, the physical model shows you how it's going to do it. Okay, those are two distinct things that we must understand. So the logical part, the logical modeling, is usually done in the initial stages before implementation, conceptual and contextual system design. When we are actually beginning the implementation process, this is when we begin, we start handling the physical. Here we're saying how technology will be involved in the functional processing of data in the business scenario. So those are the two different models that come out in the design and development process. Now here I'm going to just have a simple system development process. It's basically all the things that we've been talking, what we've just been talking about in the last two slides. When we are identifying our problem, this is the system initiation. Now in design science, you'll see it being called as the first hunch, yeah? To be referred to as when we are identifying the problem. In system analysis, this is when we begin to identify the requirements. And also design science also very nicely pinpoints this stage, discusses this, the articles that I will share with you. Then we have the system design part, when we begin to identify the best possible solution that we can have. The best possible solution. And here we can have the logical design, what interface may it have, and so on and so forth. And then we select the particular solution that we want out of the so many. Oh, sorry. That was. Then we have implementation. This is when we implement our chosen solution and we evaluate. Again, I want to repeat, evaluation is done through each stage. Now, but the final evaluation is basically to answer, give the yes or no. Have we achieved it? If we haven't, then we go back to stages 1 and 2. Yeah. Now, essentially, what we are talking about.
A question there.
Yes, please. A question.
In the final stage of evaluation.
Yes.
Who is it the customer that does the evaluation or the systems developer?
Now, one of the things we shall look at, you have a project team. That project team includes not just ICT, but other stakeholders. For example, management, users, that it will involve those people. And those are the people together that objectively evaluate whether the system, this implemented solution is achieving what it's supposed to achieve. So when we discuss in detail about project management, you realize that the project team doesn't only involve ICT, it involves several stakeholders, people who have a vested interest in the system. So those are the people that carry out evaluation. Have I answered your question?
Yes, Doctor, thank you.
Okay. Now, as we say, the project team, this essentially, as you can see, becomes a project. And in the project, you have several stages. So this particular slide is simply pointing out to you where each particular activity lies. So in scope definition or problem analysis, this is when we have what design science refers to as the initial state or the first hunch. This is when we are defining our problem and defining the scope. When we begin defining our requirements and coming up with our design, this is the system analysis stage. When we make a decision on, we begin to make decision or have a decision analysis when we begin to pull out all the possible solutions. This is the design process. Then you have the physical design and integration. This is when we actually begin to develop the system or the solution. Then you have construction and testing. Yeah, this is when you have the prototype. And then finally you have installation and delivery. This is the final stage. And this is when we also carry out evaluation, but again, all the overall evaluation. Now, first stage in scope and definition. It is important at this stage to begin to identify the sub-phases. So at this stage, you have your team, your project team members who include all possible stakeholders or representatives of stakeholders, and you define the phases of your project. When you say from this time to this time, we're going to begin identifying the problem. From this time to this time, we talk about the requirements. We can do both. You can say this will be done at this time. And then from this stage to this stage, we're going to be designing, development, evaluation, and so on and so forth. So here, you actually set the phases and you identify the tasks in each phase. You identify the resources that will be needed, you budget and schedule. This is the period of scope definition. And this is done with stakeholders or representatives of the stakeholders. And you must have someone you report to. There must be some, either to management or to overall could be to management itself and overall stakeholders when you set out when you define your scope. You also at this time clarify your limitations, the limitations of the projects, things that basically that may arise as risks. For example, there may be limitations in funds, or you might have limitations in terms of skill, that you may not have certain skills in a certain area, and you may need to bring in a third party to give support to the project team. Now, the requirements analysis stage, we already have an idea what it is. This is when we define what the system requires. You can have functional requirements, software requirements, whatever it is, you define it at this time. You even may need to define if there are new skills that may be needed, or re-engineering processes, yeah, that some new business processes that may need to be introduced. So in this stage, you may need to ask questions like, what capabilities should the new system have? What should the users of this system, what new skills should they have in order to use this system? What data is it going to capture? How will it be stored? What is the performance level? What performance level is it expected to have? What are the priorities of the various requirements? These are just some initial questions you may need that may guide you to come up with, to support your requirements analysis. So in this stage, again, we use both internal and external stakeholders. These are extremely important at this stage. Why? It's not ICT. Usually the systems that we come up with is not ICT that's going to use them. ICT will simply provide support, but it's the stakeholders essentially that use the system. So they should be able to tell you, they should be the ones who should tell you what the requirements should be. So we then come to the logical design. This is after we have identified our requirements. So this one translates the business user requirements into a system model. Yeah, the business user requirements. You see what the business says, this is how things should act. So then we model this according to the system. So we are basically depicting only the business requirements and not any possible technical design. So we don't know at this point what technology will be needed. What shall we use? What software, what language shall we use to develop? What will the hardware requirements be, and so on and so forth. We haven't yet come to that point. Now, then you have the system model. So in the system model, here you may include data or network model, some kind of picture which represents the reality, the as is or a desired reality, the as is and what we desire it to be. This is the system model. So the system model should basically indicate the improved communication between users. It should actually indicate where the improvement is coming in from, where the innovation is coming in. So the system modeling helps the analyst to understand the functionality of the system. We come to decision analysis. So this is where we actually begin to identify which technologies we want to use, what the solution will be. So in this stage, we start looking at technical feasibility. Yeah. What technical is going to be required? Do we want in relation to the staff? Let's say the users. What technical capabilities should they have? In terms of ICT, does ICT have the capabilities to handle such a system? Take an example. If you design a system which is using IA, do you have an IA expert on your team? Something that simple, just a simple question like that. may help you. Or you may find the user requirements actually do need, then you may think, oh, we may need to beef up our ICT personnel. You look at operational feasibility. Will the solution fulfill the user's requirements? With all those possible solutions that are there, the solutions that we have that we can get off the shelf, can they support the user requirements that have been defined? Should we develop something in-house? Something like that. Economic feasibility, cost effectiveness of the solution. I remember when in last year, 2020, when we started to go online, and we had set up Moodle, and I remember some people came to Umu to sell an e-learning solution. And I remember they were really talking big, really big. And the first thing I remember, I asked management, I said that I would like to remind you that somebody came here and gave us an extensive demonstration. What happened to that solution? And essentially, it was too expensive. It was a very good solution, that there was no doubt about it. But in terms of costs, it was a bit too much. So that's when management said, okay, let's stick to Moodle for now. It supports our needs. Schedule feasibility. Can the solution be designed and implemented within an acceptable time? Some things are quite urgent, and you may not have time to implement a solution. You may not have time to design something in-house. So purchasing something may be more feasible. Then there's risk feasibility. What are the probabilities of a successful implementation? Those are questions that need to be asked. What are possible risks of implementing that solution? You could even ask other questions like, if we implement it, do we have the appropriate network security levels? Are we able to apply them, and so on and so forth? So those are some of the questions you ask for particular systems. Is there any questions so far?
Maybe, Doctor, you can clarify on risk feasibility.
Risk feasibility.
Yes.
Okay. Let me just point out a solution. I think I discussed this with you earlier. When management made a decision that Umu is going to go Google Apps for our email. I remember at the time we discussed the risks. We discussed the risks to it. We had two possible solutions. We had an open source solution, and then we also had Google Apps. So the open source solution meant that we would have to have our own hardware. We manage the system ourselves, and we basically, as ICT, handle security. Now, when we were saying we're going Google Apps, essentially what we're saying is that our emails are going to be hosted on some server in the US. Now, questions were raised that the US has got certain laws about giving rights to US authorities to actually, how shall I put it, access certain data when when they are fighting against terrorism. So what that essentially means is that the US government has the right to look at communications that are on the Umu platform or on Umu email. It has the right to do that. And I remember that was one of the things that was raised. And we had to weigh in, what are the risks connected to that? And essentially we said, well, if one of the things we can do is warn the users, but the cost benefits were severely outweighed that, our need for privacy. It severely weighed that one out. And we essentially said, no, what we need to have is a policy to indicate to all Umu users that email is meant to be used for UMU business. A student communicating to a lecturer, students to students, and so on and so forth. If anyone decides to use it for anything else, then they are putting themselves at risk. Now, we then went back. Now, when we're coming to e-learning, I remember when we were coming to e-learning, some lecturers started with Google Classroom. And here we're saying no. Now, we're saying no, we really need to go Moodle. Why? Because then we control our content. Content is a big part of any university, teaching content. You begin to now talk about intellectual property rights. If UMU is teaching and I'm putting my data on Google Classroom and Google one day decides to make it public, what does that do for UMU? So there the risks outweighed the costs, and the university said no. We are now going to go to we are going to use our own system. So when you're looking at the risk feasibility, you're looking at, when we're looking at success, that you are able, that you don't have any risk that is going to curtail your business goals. Now, when, like, for example, UMU looked at its teaching content, we're saying this may be one of our competitive advantages over other universities. Yeah, that our content in certain things may be quite unique, and we don't want a situation where our content will be leaked out and then we lose our competitive advantage. So there we did a risk analysis and we said no. Have I answered your question?
Yes, please. But maybe in case like someone uses the email to communicate the content that violates the laws of the US, at the end of the day, who is answerable? Is it the university as a whole or the particular individuals who communicated? Because you said that
that is where policy needs to come out and spell it out clearly, that the user is responsible for the content they send. So for example, if a student decides to send harmful content, then the university has the right to pass on that student. That the responsibility now falls to the student, not the university, because the person, not necessarily a student, can also be a lecturer or a staff member. It becomes that individual user who is held responsible.
Okay, thank you very much.
You're welcome. Now, the physical design and integration, this is where we begin to see the translation of the business user requirements. Those that were designed in the logical model are now being turned into a system model that depicts that. Now this one, the system model now begins to depict the technical implementation of the user business requirements. So now we are now bringing in the technology within in our design process. Now, in this particular stage, we have two extreme philosophies for physical design. One is design by specification. So here you have a detailed specifications, yeah, or sort of blueprints for construction, which are clearly stating defining each component. Detailed specifications. For example, we may say, for example, in our system model, if we may say, you may have one specific business process. We can, let's say, pick out one business process in e-learning, where we indicate the requirements for a student user. A student user, what are the system requirements for a student user? The student should be able to log in, have a very clearly defined, should have an authenticated login credentials, what the student should see, what the student should view, if they are going into a particular module, maybe a course unit, what is it they're supposed to be able to do? They should be able to view, they should be able to upload content, they should be able to download content, which type of content, and so on and so forth. That is a detailed, those are detailed specifications. So this is where you have that part, that kind of design model. Then you also have the other one, which is prototyping. Yeah. Here you have something incomplete but functioning applications or subsystems. Yeah. These are so here in this particular one, you have a prototype. It is incomplete, but it's providing some bit of functionality, so that the users begin to see how it works. And then they can begin to modify it as they so wish. Yeah. So these two are a little bit different. Here, you find something has already been created, but somebody is then going to begin to make changes, or they're going to put certain applications together, or certain parts together, certain system components together to come up with something. Take an example. I'll just give you an example. If we said, if you look at Zvaste is a whole complete system which is looking at, for example, it looks at its processes starting from the bank. You start from the registry. From the registry, you go to finance. Then registry, you go to the faculties, and you see the different interconnected parts. There would also be another part where somebody says, let me pick different components. Let me get several applications with incomplete functionality. I begin from there. I begin constructing or refining my system from these different components together with an entire team. And we say, okay, to this part, add this. Now, for example, I would say, maybe a university says, let me start with school pay. Then from school pay, let's have this other system for registry. Then for accounts, let's have this one. And then we begin to see the different components working together. That is the prototyping. This is another part of the design process. So each of these, you can select them depending on what it is you want. You may have something quite detailed and then begin to pick components off the shelf. Usually when we have this one, when you have design specification, this is usually when you want to develop something from scratch, which is extremely clear. This is when you want to develop something in-house, or you want to get somebody to develop a system for you. When you clearly spell out the parts that you want to work. Then we come to construction and testing. So of course, this one comes after you have designed it comes with, basically when you have a prototype and then you implement it. So again, now here is the first thing I want us to note. Throughout the process, whether you're going to purchase something off the shelf or you're going to build something customized, it doesn't matter what it is. All the stages are followed. All stages are followed. If, let's say, I just go back to the previous slide,
Is the doctor still around?
I'm not seeing her.
Maybe she has lost connectivity.
Probably.
Is anyone calling doctor?
Yes, 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 yes. She lost the connection, but is reconnecting.
Just share my screen. Many apologies. Many apologies, please. So let me just continue. So we had looked at the design process and the two different philosophies you can use. Now, when we are using, after implementation, whether you have purchased your software or you have customized software, you go through construction and testing. This one is a must, yeah? You go through construction and testing of the software itself. You also look at the database, the user interface, the users, the system interfaces, hardware, and network, and network. So all of the components of the system go through construction and testing. Finally, you have installation and delivery. Only after you've done the construction and testing and you're sure that now this can help us, you do the implementation. So the implement the delivery of the system, we are basically putting it into production itself. We have user training at this time, completed documentation, and converting existing data into the system. All these 4 stages are now met through the installation and delivery system or stage. Lastly, you have the system operation and maintenance. So here, you may have agreed, if you have somebody supplying to you, you may agree on what their roles may be in terms of operation and maintenance. If not, you would have somebody on your team or some people or the team ICT itself is responsible for operation and maintenance. If ICT didn't develop the system themselves, there must be a relationship with the suppliers. In case of anything, if you didn't develop the system yourself, then there must be some kind of agreement about how a system is going to be supported. So here we have questions of like, where is ongoing support going to come from? Is it going to be with the current ICT department? Is it going to be from a third party? Who is going to maintain it, and for how long? How long will the maintenance process go on? Here we have just an example of the ICT project phases. It's basically what we've been talking about, where we start with scope of the scope definition, you go to problem analysis, system requirements, and so on and so forth. You can take time to read through it, but this is essentially what we've been talking about in these other previous slides. This slide simply summarizes what we've discussed, the different phases in the system development life cycle. So it's the same thing as what we've been talking about. The only thing the other thing it focuses on that we haven't talked about is acceptance by users. So part of essentially part of the system development life cycle, this section is extremely important, where there is acceptance by users. And this is where part of your assignment is going to focus on, because there are different methods which help us determine acceptance by users. Why do we add this part, acceptance by users? Remember, we said people are a part of the system. If you have users that don't accept to use the system, then that system is basically not there. You don't have an information system. What you have is an art piece. So acceptance by users is extremely important. So we have also, let me just lower this. We have what we call the project management, Essentially what we are looking at is how you as a CIO, as head ICT, how you're going to bring in a new system into this context. And essentially what that means, you are managing a project. So where does the system development life cycle fit in this particular project that you're trying to manage? Where does it come in the project management section? I don't know if you've done this module, you may have already done it. You may already know the different stages of project management. But where does the system life cycle come in? Essentially, this development process comes in first of all at the project initiation, all the way up to execution. All the way up to execution. This is where the system development life cycle fits in. We come to the next part, project management. I'm sure you've done something on this course, on this particular section. Have you not? On project management?
We have done.
Have you done a module on, pardon?
We have done one.
Yeah, so this particular course unit is not about project management, but to see where it fits. You may already have seen this, so I'm not going to waste too much time on this because it's already been a module that you've done. You know what project management is, the measures of success for the implementation is acceptable to the development life cycle. We look at acceptance by the user. do the users accept this system? You're looking at time. Is something being delivered on time? Has it been done so within budget? And there's a minimum impact with in ICT strategy, we looked at change management. So we want to see that there's minimum impact on business processes, that business processes have not been curtailed. There's what we call poor expectations from management. Now, one, we may look at scope, where you may see certain things coming in that were actually not referred to. Uncontrolled addition of technical features. These are some of the things that may affect in the system development life cycle. In project management, you're looking at basically the things we're looking at in SDLC. These are also found in project management. You're looking at scope, planning, estimating, scheduling, organizing. So it's essentially, you see, it fits into project management. What it is you want to achieve, it already fits within that particular scope of project management. So I won't waste time on this because you've done it. What I want us to look at is look at the assignment we want us to see. I have specifically targeted these, what these are called, these are theories on technology acceptance. So in the first assignment I want to give you is for you to go and read through these specific theories which look at acceptance of technology, because this is a key point that needs to be understood by all ICT heads, because we're looking at acceptance of systems. Whatever system we want to implement, if the user doesn't accept it, it becomes useless to the organization. So this is your first assignment. I want us to begin to understand some of these theories, because they will become part and parcel of you as you carry out your projects within your organization. They become something that you will use to test, to see if your technology or rather to evaluate the usability of your project. Do we have any question so far?
So, Doctor, the assignment is about the different forms of user acceptance.
No, these are called, these are theories, established theories, which look at technology adoption or acceptance or implementation. Yeah. So if you look at them, these are IT or IS implementation, adoption theories or models. So what I want you to, what I'm targeting in this assignment is for you to go and read and understand about them, because these will become tools that you will use within your workspace.
Okay, it is okay.
Yeah.
Doctor,
Yes,
I can't access Moodle. I don't know. I'm unable to log in. I don't know if anyone else is experiencing the same.
You guys are not using Zivasti, are you, to log in, are you?
No.
Or you're going in direct?
Direct using the email.
You're logging in there?
Yes, directly.
Daddy?
Yes.
You're using the email address?
Yes, the email address has a username.
But you're not accessing it?
Yeah, I cannot log in.
Is this being experienced by others?
Yeah.
I'm not
so
sure.
It's all of you. It's all of you that are experiencing it. Is it everyone who is experiencing it?
I will try to log in and give you feedback, Doctor.
Okay.
Yeah, I'm
okay.
experiencing this
If the
myself.
rest of you can let me know, then I'll talk to ICT. Rachel is saying that you have an exam due this weekend.
I lastly accessed
Okay.
it yesterday evening, I think.
Okay. So okay, I can extend this date to let me see. Give me a minute. Okay, we can extend this to, so you have, this weekend you have an assignment, you have an exam, yeah? Can you submit this then on the 3rd? Would that be okay? Hello?
We are submitting the exam on the 30th. That would give us maybe 2 days to do the same.
On the 30th. Ah, okay, on the 30th.
The 31st,
Okay,
Saturday.
So then I can push it to 6th.
Please, thank you.
This assignment to 6th, yeah?
Yes, please.
Is 6th okay?
I request we submit on Sunday, 7th.
7th.
Seventh
That
is a
is
Saturday.
8th.
But 7th
is
is a
8th.
Saturday, 8th. Unless
So
you're
let's
saying
look
8th.
at 8th then. Okay,
Yeah,
let's look
8th
at
because
8th then.
we-
So, okay, let
then
me
those-
change this to 8th. Hold on a second, let me change this to 8th of August. I'll put this up in Moodle. I'll also put up the assignment in Moodle, so where you can submit. Any other question?
No, I just wanted to let you know that I can access Moodle. Maybe I can access Moodle. I've just logged in.
Doctor, I have a
Yes, please.
question.
Yes, please.
How many assignments are we having? Is this the first one? There's somewhere where you are told us to read and write briefly, and then this one. So is this the second assignment? Or the other one was just for us to read, not really an assignment? Or rather, not an assessment? Hello, doctor?
Yeah, just put the two together. Yes, yeah.
Okay.
Yeah, this is the accessing. Can you send an email to, yes, please? The one who is not accessing, failing to log in, can you send, you can either send to Ikasozi or Dimusoke. But Dimusoke, I know is available. He's actually supposed to help me with also Moodle by tomorrow. So he should be able to help you. Just send him an email and let him know that you're failing to log in. Just give him your email address and let him know.
It's what's the full email address?
Dimusoke, let me put this in the chat. Okay. I've sent you the email address. I hope that is okay. So I'll put these slides up on Moodle tomorrow, and you can see the assignments. And we tomorrow you can use tomorrow. You can use well, like you said, you have an exam due, so we can have tomorrow off.
Yes, thanks.
Thank you very much.
Okay.
Yeah.
Okay. Okay. If we don't have any question, I'll wish you a good evening and a nice weekend.
Doctor, just a quick one. So those that are unable to access, what do they do? What will be the recommendation?
To access Moodle,
Yes.
yeah, I've send a message to Dimusoke, the email I've just sent. I've just sent you. Send an email to him. he
Okay.
should be able to sort you out. Mm.
Maybe if you could also share his phone number.
Give me a minute, let me get it.
Sit. Mhm.
Okay, I'm just going to put his phone numbers on chat. Okay, and I'll also send it on the group chat as well. I'll send you his contacts from there.
Thank you.
Okay. Okay, do we have any other question or concern? No?
No.
Okay, then I'll wish you a good evening and we meet next week on Friday.
Okay, doctor.
Okay, thank you.
Okay, thank you.
Next weekend.
David, thank you for the link.
You're
Indeed. What's the
welcome.
course unit called?